Hello everyone, this is Adnan and welcome to Chemistry with Adnan. On this YouTube channel, I'm covering the entire IGCSE Cambridge Chemistry 0620 syllabus, and the course code is 0620. In this lesson, we will be covering 4.1 electrolysis, supplement or extended topics. We have already covered the core topics in our previous lesson. So if you haven't watched that video or lecture, you go back and watch that. So there's a dedicated playlist for IGCSE Cambridge Chemistry 0620 on the playlist. And if you are affiliated with another exam, a different exam board, for example, edXL or AQA, so I have covered the entire syllabus of these exam boards as well. So you can find your relevant playlist from the search menu. I also offer one-on-one lessons if you need a private tutoring session. So the link Google form is given in the description. You can fill it and I will contact you. And also, if you need group lessons, I have a community on school.com with the name of High School Chemistry. The link is also given in the description. So you can join the community for free, and I offer one lesson per month for free. It is free of charge. It is in a free package. You can post questions in that community, and your questions will be answered. And you can interact with the students from all around the world who are studying high school chemistry. You can ask what their like a routine is, and how do they study, and what difficulties do they face. So it's exciting place to be if you are learning chemistry. Okay, so 4.1 electrolysis, our first subtopic of 4.1.8 is describe the transfer of charge during electrolysis to include the movement of electrons in the external circuit. Okay, so let me explain this one, the first one, a part A. So let's say we have this container, and the electrodes are connected to a battery here, and so one of the uh, electrodes is connected to the positive terminal, so this will be the positive terminal, and the other one, let's say it is connected to a negative terminal, so this will be negatively charged. So the negatively charged electrode, we call it cathode, and the positively charged terminal, that is called the anode. Okay, so now here they are asking about the movement of electrons in the external circuit, right? So how the electrons, they move through these wires and this battery, right? So what you need to understand is that when something has a negative charge, let's say Cl negative, when it will reach this positive terminal or positive electrode or anode, so it's going to lose these electrons, right? So it's going to lose these electrons, and the electrons that are lost on the anode, they move in through the wires, externally, right? And they enter this battery, and they are regenerated from the negative terminal of the battery, and they reach the negative terminal in the cathode, right? So the movement of electrons in the external circuit is from anode to cathode. And where do electrons come for at the anode? So they are dumped by the negatively charged ions that are called anions, right? So the anions dump their electrons, they lose their electrons to the positive terminal, and these electrons, they move you know uh, through the external circuit and reach the cathode, right? So this is the movement of electrons through the external circuit, right? Remember that. Okay, and the current, it flows in the opposite direction. If they ask you, well, they will not, but let just for extra information, the current flows in the opposite of the charge flow, right? Okay, Now now this is, you have to remember this, the flow of the charge. It is from anode to cathode. Okay, so I think I've explained it enough. And now we take a look at B, the loss and gain of electrons at the electrodes. Yeah, so again, like I just explained, that the you know the electric current is conducted in the solution through the electrolyte ions, right? So we have ions, we have positive ions, and we have negative ions in the solution. So let's say this is our anode and that's our cathode. And let's say we have X positive, and we have let's say Y negative, and we have let's say Y negative. I'll write it here, Y negative. Okay, so what will happen as this ion, which is our anion, the negatively charged, when it will be attracted towards the anode, so it's going to lose its electrons, right? And loss of electrons, that is called oxidation. So oxidation occurs at the anode, remember that. And when this positively charged ion, the cation, it will be attracted to the negative, which is cathode. So it's going to gain these electrons. So gain of electron is reduction, so reduction will occur here, right? So remember, you can remember this by an ox, the ox, the animal. So N means anode and ox means oxidation. So oxidation will always occur at the anode. And red cat, so cat, the animal, and red means reduction, right? And cat is for cathode. So reduction at cathode, red cat, and oxidation at anode, and ox. So this might help you remembering this concept. Okay, now we move on to the next part, the loss and gain of electrons, the movement. Yeah, so the loss and gain of electrons at the electrodes. Yeah, so to summarize this concept, we can say that oxidation occurs at anode, and or you can say that electrons are lost. So I'm going to write here, electrons are lost. And for cathode, electrons are gained at the cathode. Electrons are gained, right? Okay, so now our next topic is C, the movement of ions in the electrolyte. So yeah, so let me just draw this again, this container. And let's say this is a positive terminal and that's the negative terminal. Like these are the positive and negative electrodes. So in the solution, as I've explained it earlier, that we have electrolyte, and electrolyte can split into positive and negative ions, right? And so like in nature, anything that has a positive charge will be attracted towards the negative, and anything that has a negative charge, it will go to the positive, right? So the movement of ions in the electrolyte, so anions with the negative charge, they move to anode because it has a positive charge. So ion and electrode. And cations that carry a positive charge, they move towards the cathode that has a negative charge. So remember this, right? So and this is only true, this is true for electrolysis, right? Like electrochemical cells. So especially in electrolysis, in a lead acid battery, this might be different because, but since that is not included in our syllabus, so we are not going into that discussion. in a lead acid battery, these charges on the electrodes may flip, right? So I'm just making a comment here so that you don't get confused. But yeah, so as long as we are studying electrolysis, so the anode will have a positive charge and cathode will have a negative charge, and there is no contradiction like in this. Okay, so now we move on to the next topic, which is topic 4.1.9, which says that identify the products formed at the electrodes and describe the observations made. Again, so you can see that this segment, this topic has two requirements, right? And the first one is the product, identify the products formed at the electrodes and observations. So products we have to identify separately, and we have to note down or write down the observations made during the electrolysis. Our electrolyte is copper 2 sulfate. So copper 2 sulfate has a formula CuSO4, because remember that copper is 2 plus, since it says that copper 2, and sulfate has a 2 negative charge. So if you apply crisscross method, so this gives us CuSO4. Okay, using inert carbon graphite electrodes and when using copper electrodes. Okay, so we will have to study the electrolysis of copper 2 sulfate in under two scenarios: aqueous copper 2 sulfate, not molten, remember that. So it's aqueous copper 2 sulfate. We have to study it under two conditions. The first condition is using inert carbon graphite electrodes and using copper electrodes, right? So now let us try to understand it step by step. So I would like to again mention again that since it is aqueous electrolysis, so there will be involvement of water, right? So CuSO4, when it is dissolved in water, it splits into Cu2 plus and SO4 2 minus. But since water also ionizes into H plus and OH minus, so you need to understand here that we will have two types of positive ions, and we will have two types of negative ions, right? So we also okay, now let us review the rules again. So rules for the cathode. Cathode has a negative charge. So what can be deposited at the cathode? It is you have to look at the reactivity series, right? So reactivity series, and a less reactive element, or less reactive, less reactive element is deposited, right? And the less reactive element, which will have a positive charge, it will be attracted to the cathode. And for the uh, anode, the rules are anode. So only two products can be deposited. Only two things can be deposited at the anode that contains a positive charge. It may either be oxygen or a halide, right? Okay. So in this case, since there is no halide in copper sulfate, so for at the anode, it will always be oxygen without any exception. And for cathode, since if you look at the reactivity series now, so you will find that copper is less reactive than hydrogen, right? So I'm not writing the entire the reactivity series, but if you look at the reactivity series, so it's lead, and then it's hydrogen, and then it is copper, right? So copper is lower in the reactivity series than hydrogen. So that makes hydrogen more reactive than copper. So copper being the less reactive element, copper will be deposited at cathode, right? So Now, and these are like when we are using carbon and graphite electrodes. Okay, let's say these electrodes are made up of graphite, and let's label this one positive. That this will be the anode, and this one will be the cathode with the negative charge. So now we have you know Cu2 plus from the copper 2 sulfate itself, and we have hydrogen from water, H plus, and we have SO4 2 minus, the our anion from copper 2 sulfate, and our cation will be another anion from water will be OH negative, right? Yeah. So now we have two positive ions and two negative ions. So we need to understand which one will go to the anode and cathode. So positive one, this is anode, and the negatively charged is cathode. Okay. So again, if you look here, I've written these rules here for you. So if we are looking at the cathode, so less reactive element is deposited. So less reactive is copper. So at cathode, copper will be deposited. And what will be the observation? There will be brown color, at the cathode, because or yellow brown, because copper atoms, they have a brownish, golden brownish color. And what will be deposited at anode, that is going to be oxygen, because we do not have any halide. So sulfate doesn't play any part here. So at anode it will be oxygen, right? Okay, so if you have any questions, you can about this topic, you can leave it in the comments below. And now we move on to the next part, right? Okay, so oh, okay, so all right, so yeah, another thing I would like to mention here, that the copper, it has a brown color, but in a solution, the color of copper sulfate solution, it is blue, right? And this blue solution, this blue color, it will fade out, right? It will fade. Why? Because this blue, the copper in the form of 2 plus ion, when copper has a 2 plus charge and it is dissolved in water, it gives water blue color. But since copper is being regularly deposited here at the cathode in brown color, so the blue color, from the solution, it will fade, right? And eventually, it may become colorless when all the ions from the electrolyte, they get deposited onto the cathode. So this is a very important point that you have to consider, because this is what is the requirement of this student learning outcome, SLO, that we must explain the observation and the product as well. So this is the color part that is related to the observation, that what we will see happening here. So I hope this is clear, and this is when carbon or like graphite ions are used, right? So now let's take a look at the next one, topic 10, 4.1.10. Predict the identity of the products at each. Oh, no, I think I have to now explain the same thing using the copper electrodes. Okay, let's do that. So we have this container, and now these electrodes, they are they are not made of graphite, they are made of copper, right? So one copper electrode is connected to the positive terminal of the battery, so it will get a positive charge, and the other one is connected to the negative terminal of the battery, so it will have a negative charge. And the positive one is called the anode, the negative one is called the cathode. These are our electrodes, and they are made of copper, right? So copper electrodes. Okay, and so now we have a solution, Cu 2 plus and SO4 2 minus, SO4 2 minus, and since it is aqueous solution, so we will also have H plus and OH minus, right? Okay, now so this anode, it is made up of copper, right? So you must understand this. You don't forget this. Okay, so now copper is reactive, right? So it will react within the electrolysis process. So now let me explain. So this method, you should understand that it is also, it has a industrial application, that it is used for the purifying. It is used for purifying copper. It is used and it is also used in the electroplating process, right? So now in this solution, we also have Cu2 plus ion. Okay, so when the process will begin, what will happen, right? So the copper anode, it will dissolve. So copper, atoms, they will start they will start to lose electrons, and they will be released in the solution in the form of Cu2 plus, right? And the solution also contains copper 2 plus, because we have added copper 2 sulfate as an electrolyte, right? So what will happen, as these ions from the solution, they start getting deposited on the cathode. So copper, right? Solid copper, brown in color, and this cathode. So this copper electrode, it will start to increase in mass, because atoms are being shifted from the anode, and they are being deposited at the cathode. So copper, this electrode, it is made up of copper. So it contains copper atoms, right? So copper, it is made up of copper atoms. So atoms, they lose electrons and they change into Cu2 plus, and they travel all the way towards the negatively charged copper electrode, the cathode, and they get reduced. They gain electrons here, and from Cu they gain 2 electrons, and from Cu2 plus they change back to copper. So what is happening? What is happening? This anode is shrinking in size, and it is decreasing in mass, and this copper electrode, the cathode, it will be it is increasing in mass, right? It is getting bigger and bigger, because atoms are being continuously deposited on this electrode. And what will happen to the concentration of copper 2 ions in the solution? It will remain the same, and it will remain blue, right? So it stays constant, because because whenever these ions are removed from the electrolyte, from the solution, the more copper 2 ions from anode, they take their place, right? So this is the observation part. And yeah, but what will be the products at the cathode and anode? That remains the same. It will be copper at the cathode, and oxygen gas at the anode, because we don't have any halide, and only halide and oxygen can be deposited. So I hope this concept is clear. So at the anode, copper ions are being oxidized, and at cathode, copper ions are being reduced. So at the anode, copper is oxidized, right? Because loss of electrons is oxidation, and at the negative electrode, the cathode, copper is reduced, and it gets deposited on cathode, right? So I think I've explained it, and yeah. Now we want this, predict the identity of the products at each electrode for the electrolysis of a halide compound in dilute or concentrated aqueous solution. So I think we have already talked about this. So you know, so if we have a solution containing, for example, potassium chloride, and it's a concentrated solution, so and it's the aqueous electrolysis, right? So we will have K plus and H plus from water, and we will have C minus from potassium chloride, and we will also have OH negative from water. So this is positive electrode, this is negative electrode, our cathode. So what will happen? Chlorine, a halide, it will be deposited at the positive terminal, and you will see a pale yellow colored gas liberating at the anode, and yeah, and here, since potassium is more reactive than hydrogen, so at the negative electrode, hydrogen gas will be deposited, right? So and the same, so for concentrated, halide is deposited, and if we have a dilute solution, right? So but again, this uh, uh, difference between dilute and concentrated is addressed in edXL syllabus, but not in Cambridge. I haven't seen questions on the papers where they explicitly differentiate that what will happen when dilute solution is used or concentrated solution is used, right? So I hope this is clear, and it will be more clear when we solve more questions from the, like, when we actually solve questions from the past papers, right? So now okay, let me just look at this again, and to make sure that I am not skipping any topic. Predict the identity of the products at each electrode for the electrolysis of halide compound in dilute or concentrated solutions. Yeah, so this is it. So and the rest of it will be covered in when we will practice past paper questions. So the last topic is construct. So this last topic is topic 11, 4.1.11, chapter 4. Construct ionic half equations for reactions at the anode to show oxidation, and at the cathode to show reduction. Okay, so this is the topic where many students, they find it difficult, right? So now, what is a half equation? Half equation is you start with an ion, right? And it may be a positive ion or a negative ion, and on the right side, on the product side, that same ion is going to change into a neutral compound, right? A neutral compound, or element, right? So this is what a half equation is. Remember that. So again, what is a half equation? You start with ions, negative or positive, and you change them into their neutral state. If you have a neutral, yeah. So now So again, now let us study these two cases separately. So scenario A, case A, we have a positive ion. For example, we start with aluminum 3+, right? So the half equation for this will be, so in order to change it into its neutral state, it must gain electrons, right? So it will gain 3 electrons, right? So 3 electrons will be gained, and it will be changed into a solid aluminum, right? So I hope this is clear. So you write here solid, so you write here AQ, right? Okay. So yeah, this is, since electrons are being gained, so you should know that cations, positive ions, cations are reduced in half equations. And so for case B, let's say we have a negative ion, so Cl minus, and we have to write a half equation for chlorine negative, right? Chloride ion. So it's gonna lose an electron, and it will change into Cl2. You have to write the standard state, right? And it will lose an electron. So to balance this equation, now you start with, you put 2 here and you put 2 here, and now the equation is balanced. So this is, don't forget to write the state symbols. It is G, gas, and this is in a solution, so AQ. And yeah, so now you can see that anions that carry a negative charge, anions are oxidized in while writing the ionic half equations. So oxidized. So this is how it's done. And yeah, so now let us see, let us take a look at it further. All right. Yeah, so now let me give you some examples where you can study this more effectively. So let's say we are conducting electrolysis on concentrated sodium chloride, right? NaCl, and we need to write the ionic half equations for these. So so let's say we have we have Na plus and H plus, since it's a solution. So, and Cl minus and OH minus, and now since at the cathode hydrogen will be deposited, H2, and here at the anode, uh, chloride will be deposited, right? So hydrogen, so H plus from the solution, so it's going to gain electrons, right? So E minus, and it is going to change into hydrogen. But the standard form of hydrogen gas is H2. It's a gas. So you will put 2H plus and 2E minus. So each hydrogen will gain one electron. So the total electrons will be gained. So this is the half equation. The half equation at cathode, right? At the cathode. That has a negative charge, and then a half equation at the anode. It is going to be, since it is chlorine, so this one, right? So 2Cl minus changing into Cl2, releasing 2 electrons. So again, don't forget the state symbols. So this is AQ, and you start with AQ here, and this is a gas, right? And yeah, so this is how you write half equations, and the rest of it will be covered in our upcoming practice session, where we will be covering the uh, past paper questions based on this topic. Since this topic is very extensive, so I don't want to cover everything all at once in the same lesson. So there will be another lesson, part 3, where we will be focusing on the past paper questions for this chapter 4, electrolysis. So yeah, this will be all from my side. And again, I would like to remind you that you are more than welcome to join my community on school.com, skool.com. The name of the community is High School Community. It is absolutely free to join. You can subscribe to a premium package as well, where you will be able to attend 4 lessons per month, once per week, where we are covering the entire IGCSE Cambridge chemistry syllabus. We can interact in our live sessions. You can ask me questions, and you can understand this content in on a much deeper level. And if you don't like group lessons, so I also offer one-on-one tutoring sessions, and you will have to fill out the Google form that is given in the description, and I will reach out. So okay, this will be all for today. I'll see you in the next one. Take care. Goodbye.